Assalamu alaikum, dear students of Standard 11. How are you? Hope you all are safe and sound by the grace of Almighty in this pandemic situation. I am also fine. So welcome back to my physics class. Today I will explain some topics from thermodynamics. That is your first chapter of physics second paper. And today I will explain application of Boyle's law in isothermal and adiabatic process. So let's start the class. Boyle's law. At first you have to know what is Boyle's law, and I hope you already well known about it because in HSC level you have read it especially in chemistry. So Boyle's law states that at constant temperature the volume of a given mass of a dry gas is inversely proportional to its pressure. That means at constant pressure the volume of the gas is inversely proportional to its pressure. So let's try to understand it. So I have already told you pressure and volume is inversely proportional to each other here according to Boyle's law, and when temperature remains constant. So P is proportional to 1 by V. That means pressure is inversely proportional to volume. So we can write PV equal to constant. So mathematically it can be expressed in this way: P1 V1 equal to P2 V2 equal to P3 V3 equal to constant. That means the application of Boyle's law can be written as P1 V1 equal to P2 V2. That means initial pressure and initial volume equal to final pressure into final volume, where P represents the pressure of the gas and V represents the volume of the gas. But here you have to remember temperature must be constant. Look at this figure. Here some gaseous substance are taken in the cylinder and there is a piston which is tightly fitted on the mouth of the cylinder. Then if I keep a mass on the cylinder, on the piston of the cylinder, then we can see the volume becomes this. Then if I give here 2 mass on the piston, then the volume will be decreased. That means here pressure will be increased by giving 2 mass on the piston and the volume will be decreased. Again, look in this picture, I have given 4 masses on the piston. As a result, more pressure is applied and the volume is decreased more. So what can be understood from here? That means pressure is inversely proportional to volume. So look here, the initial volume was 1 liter and the pressure applied was 100 millimeter per mercury level, and here look, pressure becomes 200, so volume also becomes volume will be decreased and that will be half than that of the previous one. So it represents what? P1 V1 equal to P2 V2. So if I want to draw a graph between P versus V, that means pressure versus volume, then the graph will be like this. That means with decreasing pressure the volume will be increasing, or with decreasing volume the pressure will be increasing. In this way you can explain this graph, which represents that P is inversely proportional to V, 1 by V. P is proportional to 1 by V. So look here, by the indicator you can see the temperature remains constant and heat is supplied to the system, and pressure is, if pressure is increased, look here on the cylinder, the gaseous substance is taken in the cylinder, and look here there is some lines are drawn which is indicating the amount of volume. So here by increasing more mass, that means by increasing pressure, the volume will be decreased and the graph will be like this, pressure versus volume graph. So how did Boyle get this law and how did he prove mathematically found the formula P1 V1 equal to P2 V2. Look, Boyle did one experiment, in which experiment he took some gaseous substance in a cylinder and he kept some mass on the piston. Then he saw that when pressure is increased, volume is decreased. So look here, if P1 equal to 2, then V1 becomes 5. Then again, if P2 becomes 5, then V2 becomes 2. So look here, P1 V1 equal to what? 2 5s are 10. Here P2 V2 equal to 5 2s are 8, 10. So what can we prove from here? That means P1 V1, I have told you P1 V1 equal to P2 V2 equal to constant, and that is, look here, in the both cases we got the product, the value of the product is 10. That means it is constant, and that is Boyle's law. So dear students, Boyle's law is applicable on when there is temperature constant. So temperature is constant in a thermodynamic process that is known as isothermal process. That's why in isothermal process Boyle's law is directly applicable. That means for isothermal process we can write P1 V1 equal to P2 V2. Now I will show you the application of Boyle's law in case of adiabatic process. So adiabatic process is which process you know, where there is no exchange of heat and the gaseous substance is kept in a cylinder whose wall is insulated, thermally insulated. So here the exchange of heat is 0. That means del Q equal to 0. So look here, when the piston is taken outward, then the pressure will be decreased and the volume will be increased. Have you seen? So here also Boyle's law is applicable, but here Boyle's law can be written in this way. That means PV to the power gamma equal to constant. And here this is the curve which we get for adiabatic process. Here also pressure is inversely proportional to volume, but here by calculating the change of pressure and volume, Boyle got the formula, that is PV to the power gamma equal to constant. That means pressure into volume to the power gamma. Here gamma is what? You know in the previous content I have explained, gamma is the ratio of Cp and Cv. That means the molar specific heat at constant pressure by molar specific heat at constant volume is a constant which is known as gamma. That mathematical index is known as gamma, and you know gamma has different value for different type of gas. That means for monoatomic gas, for diatomic gas, or for polyatomic gas. So when in case of adiabatic process, I have told you it is here temperature is not constant. So what is constant here? What is that means heat is constant. That means no heat is exchanged. There is no exchange of heat. The del Q equal to 0. Nothing is constant here, but del Q equal to 0. So for that purpose, here the Boyle's law is applicable, and that can be written in this way. That means PV to the power gamma equal to constant. Okay. Look, this is isothermal curve and this is adiabatic curve. Can you tell me which curve is more steeper? Steeper means khara. Look, obviously this one is more steeper than that of the isothermal curve. This is why because of this gamma. Okay, because of this power, gamma is used as a power of volume. That's why adiabatic curve is more steeper than that of the isothermal curve. So in adiabatic process, I have told you del Q equal to 0. Look, here some gaseous substance are taken in a cylinder, and look, this gold color, it represents that this is made of insulating material. That means It is made of insulating material so that no heat is exchanged from inner to outside or outside to inside. The piston is compressed so that there are no heat exchange. Temperature and internal energy is raised. So here heat is not passed through, but here temperature and internal energy is raised, and I have explained that in my previous content what is adiabatic process. So for adiabatic process, the relation between pressure and volume can be written as PV to the power gamma equal to constant, because you know the different gaseous substance has different value of gamma. So here that gamma will be used as power of the volume, and the relation between temperature and volume is TV to the power gamma minus 1. You can remember in this way, টিভির দাম গামার চেয়ে 1 কম। TP to the power 1 minus gamma by gamma equal to constant. So the applied form of this formula is Pi Vi to the power gamma equal to Pf Vf to the power gamma. That means initial pressure and product of pressure and volume equal to final product of pressure and volume. So Pi, that means initial pressure, Vi to the power gamma, that is initial volume, and Pf, that is final pressure, and Vf, that is final volume. Then for TV, temperature and volume, this relation can be written as Ti Vi to the power gamma minus 1 equal to Tf Vf to the power gamma minus 1. And in case of Tp, that can be written as Ti Pi to the power 1 minus gamma by gamma equal to Tf Pf to the power 1 minus gamma by gamma. Dear students, I will derive one equation, mathematical derivation. I will show you one mathematical derivation, by which mathematical derivation it will be clear to you how adiabatic process, how adiabatic curve is steeper than that of the isothermal curve. But before explaining that, I want to give you this formula, because for that derivation we will use differentiation, and here is the rules of differentiation. Okay, that means rules for calculus, differentiation and integration. There is also some rules here. Many rules are given, but we will use very few rules, like this top 3 we can use today. So no need to memorize this, you just understand. d by dx of x equal to 1. That means আমরা যার সাপেক্ষে এখানে d by dx মানে x কে আমরা dx এর সাপেক্ষে আমরা ডিফারেন্সিয়েশন করছি, তাহলে কি হবে? That will be 1. d by dx of x, here a is constant, and we will differentiate x with respect to dx. So dx by dx equal to what? 1. From here you can see. So here it will be only a, and when any constant will be used, then that constant will be taken outside of differentiation. So here it will be a into dx by dx, but dx by dx equal to 1. So simply we can write as a. Look, this formula, d by dx of x to the power n equal to n into x to the power n minus 1. That means which power is used here, that will be at first, then 1 will be subtracted from that power. Okay, so here if we use here 2, that means x square, then it will be 2 into x to the power 2 minus 1, that is equal to 2x. If we use here 3, then it will be 3 into x to the power 3 minus 1, that will be 3x square. So I want to tell you one thing. You must tell your mathematics teacher to whom you are learning mathematics to show you some simple formula of differentiation, and I hope that will be more clear to you then, and you can use differentiation or integration in case of physics, because in physics second paper calculus is mostly needed. So now I will show you one mathematical derivation. Why is adiabatic curve more steeper than isothermal curve? So look here, isothermal curve, and that is adiabatic curve, and obviously it is seen adiabatic curve is steeper than that of the isothermal curve. But why? So we know the ideal gas equation for isothermal process is what? PV equal to constant, because I have told you isothermal process follows Boyles law. So PV equal to constant. Now we will differentiate this equation, equation 1, then we can get, we will differentiate this equation with respect to volume. So d by dv of PV equal to 0, because if we differentiate any constant, then that becomes 0. Here P and V, that means pressure and volume, are in the are used as a product, are in the multiplied form. So in case of multiplication, the differentiation rule will be like this. That means at first you will take P outside and you will differentiate volume, and then V outside and you will differentiate pressure, equal to 0. So P dV by dV equal plus V dP by dV equal to 0. So here in both cases the denominator is dV. So we can write P dV plus V dP equal to 0. That means dP by dV equal to minus P by V. So here dP by dV is the slope of isothermal curve. So dP by dV for isothermal process equal to minus P by V. Again, in case of adiabatic process, the ideal gas equation becomes PV to the power gamma equal to constant. Now again differentiate this equation, equation 2, we get what? Look, here PV to the power gamma, that means that is also used as multiplied form. So P into that rule, you know, d by dx of x to the power n. You will use that formula here. So here in place of x, here you can here we are seeing v, and in case of n, here the power is gamma. So but you will use that formula. So at first p will be taken outside and you will differentiate v to the power gamma with respect to volume, and then v to the power gamma will be taken outside and you will differentiate pressure. And if we differentiate this constant, that will be 0. So P gamma into V to the power gamma minus 1 dV equal to V gamma into dP equal to 0. So from here we can write dP by dV equal to minus gamma into Pv to the power gamma minus 1 by V to the power gamma. Look, if I take this in this side, then it will be minus, isn't it? Then dP by dV, and in this way, by changing the position, dP by dV for adiabatic process becomes minus gamma into Pv to the power gamma minus 1 by V to the power gamma. Minus gamma Pv to the power gamma minus 1 into, it is divided, so it can be written as V to the power minus gamma. But V to the power minus gamma and V to the power plus gamma is what? We can cancel each other. Okay, so it will be minus gamma into P V to the power minus 1 or V inverse 1. That means minus gamma P by V. It can be written as minus gamma into P by V. So from equation 1 and 2, that means in isothermal process we got dP by dV equal to minus dP by dV equal to dV equal to minus P by V, and here dP by dV equal to minus gamma by gamma into P by V. So we can write dp by dv for adiabatic equal to gamma into dp by dv of isothermal, because minus p by v equal to what? Minus p by v equal to dp by dv of isothermal. So dp by dv of adiabatic divided by dp by dv of isothermal equal to gamma. That means the slope of adiabatic divided by slope of isothermal equal to gamma. That means the slope of adiabatic curve is gamma times steeper than that of the isothermal curve. This derivation is given in your book that you can follow, Amir Hussain, Dr. Amir Hussain, and or you can follow Dr. Shahjahan Tapun. Any of the book can be followed, and by following those books, you will write down this derivation in your copy. Then it will be more clear to you. So here, for isothermal process, temperature is constant, and here we can write PV equal to constant. And you know, in isothermal process, temperature is constant. That's why del U equal to 0 and del Q equal to del W. I think this chart will help you more for understanding the math. For isobaric process, which one is constant? Pressure is constant. Isobaric. Iso means same and bar means pressure. So same pressure. Pressure constant. So here V by T equal to constant. And here del Q equal to del U plus del W. For isobaric process, volume is constant. So P by T equal to constant and del W equal to 0, because you know volume is constant, there is no change of volume, so no external work done, and del Q equal to del U. For adiabatic process, no heat flow between system and surrounding, so here PV to the power gamma equal to constant, and in this case del Q equal to 0 and del U equal to minus del W. We have to remember this chart. So dear students, I think you have understood the class, and if you have any problem you can consult with me. And for understanding physics, I have told you calculus is mostly needed. That's why you must try to understand some simple rules of calculus, and for that reason I have given a chart of the rules of calculus. You will follow that, and if you have any problem, then you can also consult with your mathematics teacher. I think then that will be helpful for you. So in the next class, I will explain the work done of different thermodynamic process. Until then, you must stay safe and sound. So goodbye.